Okay.
Recording in progress.
Can you hear me? Can you hear me?
Yeah, sure. Thank you.
Okay. So I share my screen. Okay, see my screen?
Yeah.
Okay. So first of all, I imported my country boundary shapefile Bangladesh. Then I call my dataset. So you can see here, where is dataset? So this is the dataset for Landsat 8 NDWI 8-day NDWI composite dataset. I just simply copy this collection snippet. Okay, I just simply copy this collection snippet. I paste here, and I gave this dataset name is I gave this variable name dataset. Okay, dataset, and after this I filter this dataset. Sorry, so this is the dataset. I simply use here the dataset, and then I use here the filter for the specific time period. I simply use here the filter. Then I define how I can filter, or what's the item I want to filter. I want to filter this date. I simply use here the filter, then date, and then I simply use here my specific start and end date. So first of all, my start date, I define here the start date, suppose year of 2018. Then this 1st April, I define here the 1st April, and then end date, I define here the end date. Suppose the end date is the 2018 June, then 1st June. Okay, I randomly put this date. This is my observation date, and then I select my specific band. Suppose I take a variable var, then I cap this variable name is the NDWI, and then I just put here this, call this dataset variable. I simply use here the dataset, then I simply select my specific band. In this time here you can see this dataset has the only one band. This band name is NDWI. I just use this band, so this is the NDWI I put here, and then I simply use here the, suppose I want to work with for the mean NDVI, or I also get from here the mean pixel value of this NDWI. So I use here the take a variable, then gap this variable name is mean NDWI, and then call this NDWI. Then I use here the reduce. So reduce is a statistical function, and then I defined how I can reduce. I use here the mean, so I simply use here the ee dot reducer dot mean. Okay, and then I want to clip it with my shape file, so I simply use another variable. This variable name is the study area, and then I call my mean and DWI result. So I simply paste here, and it will be clipped with my geometry. In this time my geometry variable name is the table, because this table variable included my shapefile Bangladesh, so I simply put here the table. Okay, so now I want to check this result. I simply use here the map dot add layer function, and after this I call this study area, simply paste here, and then I also focusing this shapefile. I simply use here the map dot center object. Okay, and this is my table, and I also prepared the zoom level is a 10. Click on the run. Okay, so now you can see it will be appeared, but this result is not good way. With this is the not the colorful map. We can get here the total black and white map. Yeah, so now I want to colorize this map. So you can get some default color code in here. So just I simply copy this color code from here and paste in my code editor. Okay, and after this I just simply copy this visualization parameter variable name. Here they make a dictionary and put here the mean pixel value. It will be showing the mean pixel value will be start from the 0, and max pixel value is the 1. Between the 0 and 1 it will showing the all of this pixel value. and they also use the different types of color palette for showing this result colorful. And then I simply use here, paste here this object after the object, and we already know that after the object name we always state here the visualization parameter. Okay, so that's why I simply paste here the visualization parameter variable name, I paste here and then click to the run. So now we will get this good result, you can easily understand, and we can easily identifying the water in the surface. Okay, so this is the ready-madely data on the Google Earth engine, and this data set is the 8-day composite. Okay, so now if you want, you can make a time series chart of this data set. You can get the every 8-day interval value, you can get the every 8-day interval value easily, you can access here. Okay, so this is the 8-day interval data set, you can easily get this interval value, and this is the same way for the MODIS. So just you can simply search here the MODIS. Suppose I simply search here the MODIS. Actually, which data set you want to need, you just search in the top of this code editor. If this is search bar, you just search here. Okay, suppose I want to search the MODIS. This is the MODIS NDWI. You can see the different types of composite: 60-day, MODIS Aqua daily NDWI, MODIS Terra daily NDWI. I simply click to here 60-day NDWI. Just I copy this collection snippet, I just simply copy this and I paste here. Okay, I paste here, simply paste here. So now this I can get this image for the MODIS NDWI, and you can also check here the MODIS NDWI has the same band name. Okay, we can get the same band name here, you can see this is same band name, but it is the pixel, the resolution is, you can see 463, but when you use the Landsat we can get only the resolution for the 30 meter. Okay, so this resolution is high than the MODIS. Okay, so just I paste this code link and click the run. Now I can get this image for the MODIS satellite image. Okay, so it will be appeared, you can see, but this resolution is not good. Okay, so now if you want, you can make this time series chart for this, then you can get this every 60-day interval time series value. Okay, so I already discussed about that, how you can easily make the time series chart. Okay, for the image collection. So when you work with the image collection and you want to make the time series chart for this image collection, you just use this function UI chart dot image dot series. This function, actually this function you can work for the when you make a time series chart using the image collection. So this is the image collection, so that's why I use this function when I make the chart for this. Okay, so any question? And this dataset is a 60-day composite, so I can get the every 60-day interval value. So any question, anyone? And I will send you all of this code so that you can also practice. So any question, anyone? You can ask me. No question or no doubt? Then I will move to the next slide. And you can also import it, this satellite as a TIFF format. This is the same way. You can use this function export dot image to drive. Okay, you can put all of this argument one by one, put all of the argument one by one, image, then description folder. You will put all of this argument one by one, and then you can easily export this image as a TIFF format and work with this the ArcMap or QGIS software easily. Okay, so any question, anyone? Or any doubt? If you have no question, then I will move to the next slide. Okay, So I will move to the next slide. So in this time I will try to discuss about the some my research project and research work which I done with the Google Earth Engine platform. So after this, if you have a idea what's the tasks of remote sensing you can do using this platform, okay. So first of all, you can see this is the web application for the making the time series chart for the NDVI, and this is the chart NDVI over time in Bangladesh. Anyone can using this web application. This is the web application link or app link. Anyone can use this app for make the time series chart for the any specific point in Bangladesh, okay. You can easily access this app using this link. Then this is the another task for the Moody's Leaf Area Index, okay. This is the another web application using the JavaScript API with Google Earth Engine platform. So you can easily make the time series chart for the any area in the world for the monitoring the Moody's Leaf Area Index. This is the web application link. You can easily access this app using this link. So this is the another for the chart inspection of the EVI and DVI trend. You can easily get any point. So this is the web application link. You can easily access this web application from this link. So this is the another for the Bangladesh precipitation map year of 2020, and I make this map in the Google Earth Engine platform. And this is the another for the Dhaka city land surface temperature year of 2020, and this map I will create it in the Landsat 8 satellite imagery. So this resolution is so high, but Moody's Landsat is not better than the Landsat 8, okay. So this is the another task for making the land surface temperature using the Landsat 8 in the Google Earth Engine platform. So this is the another for the whole Landcover classification map for the whole world in Bangladesh. So here I define the whole world country boundary shape file. So for Bangladesh, I make the Landcover classification and land use classification map of Bangladesh. So for the better view of this map, you can easily go to this link and you can easily get the better view of this map. So this is the another task for the assessment of the plant health status in Bangladesh year of 2020. Here you can get the health status of plant. So this is the another for the water quality monitoring using the Google Earth Engine platform. Here you can see mainly in this time I will try to determine the change in turbidity, okay. So here I use the Sentinel-2 satellite imagery, and I also do for in the Google Earth Engine platform. So this is another for the nitrogen dioxide concentration. So basically in this time here I use the Sentinel-5 satellite imagery, and tomorrow I will try to show you this part. So how you can also make the air quality monitoring using the different types of parameter, nitrogen dioxide, sulfur dioxide, carbon monoxide or other, okay. So this is the another task for the cropland classification of Bangladesh. So here you can see we divided the no croplands, then croplands irrigation major, then cropland irrigation minor, okay. So you'll classify this the different way. So then this is the flood mapping using the Sentinel-2 satellite imagery. So mainly in this time here I use the Sentinel-2. So and the tomorrow I will try to show you this project how you can also do this. So this is the another for the night light map of Bangladesh. So here you can see this light map activity. We also created this dataset in the Google Earth Engine. Google Earth Engine has a dataset, so we can mainly using this dataset and you can make this map like this. Here you can see this the forest area, this the forest area and hill tracts area, and you can also see that this is the different types of the river, okay. So it will be totally black color, so it means that there is the no activity at the night time. But you can see every city, every main city or Dhaka city, you can see this is the Dhaka city or other main central city, this is the light. It means that there has a lot of activity in the night time, okay. So this is the another task for the sense trend of the forest in the gross primary production Okay, gross primary production. This is the time series for the year of 2000, 2010 and 2020, and mainly in this time all of this work I will do in the Google Earth Engine platform, and then I make this tip format and work with the ArcMap software. Okay, so this study area is the Sundarban. So then this is the another work for the relationship of the land surface temperature and normalized difference built up index. So here I also do using the Google Earth Engine platform. After this I just download this as a tip format and work with my ArcMap or QGIS software and make this map layout like this. Okay, so this is the another for the detecting the wildfires in the California. On this time you can see, and mainly in this time here use this satellite using the Google Earth Engine platform for detecting the wildfires in California. And this is the app link. You can easily go to this app link and get this visualization, get the better visualization. Okay, so this is the another for the drought monitoring using the SVI. It means the Standard Vegetation Index. So we can easily monitor the drought monitoring and also make the time series chart for the drought monitoring using this SVI. So this is the app, so you can easily access this app through this link. So this is the Spectral Unmixing using the Google Earth Engine platform. So mainly in this time I will develop the linear spectral mixing model, and we will classify here the built up water and vegetation using the spectral unmixing model. So this is the another for the snow cover map. So we can do the lot of advantage, and we can do the different types of research and project work using the Google Earth Engine platform. So this is the Landcover classification district map for the Habigonj district. This is the Bangladesh district. Okay, so we can also make the time series chart using this the platform, Google Earth Engine platform. So this is the cropland classification map. So in this time here this is the Panjab of Pakistan state of the Panjab. So here I mainly try to show you that the different types of crop classification, rice, cotton, maize and other crop I will try to classify. So this is the another for the mapping change in the nitrogen dioxide concentration in Dhaka city district. So mainly in this time, this is the COVID session, this is the pre-lockdown, lockdown and post-lockdown. We will try to a special distribution of the nitrogen dioxide concentration, okay, using the Google Earth Engine platform. After this I will make this map layout in ArcMap software. Okay, so this is the another for the classified land cover classification map of the Bhasanchar. It is also the time series analysis. So we can also find out the settlement at the year of 2020. Here you can see. Actually we also lot of works in the Google Earth Engine platform. So this is the another for the elevation map of Bangladesh, and I also do in for the Google Earth Engine platform for making the elevation map in Bangladesh. So this is another for the Bangladesh annual average precipitation. Actually lot of works and research we already done using this platform. So this is the another for the land surface temperature classification map of 2050 and 2017. So here there are different types of the land surface classification. We divide the classification low, sub-high and high. Okay, so this is the another for the detecting the NDVI change NDVI trend. Okay, so this the so thank you for watching this. So now if you have any question you can ask me. Actually we can do the lot of remotely sensed work using this platform. So if you have any question you can ask me.
Yes, can I ask a question, please?
Yeah, please.
You actually used a lot of precipitation data and for DWI and precipitation maps. Did you only use satellite measurement, or you have to have ground station for measuring rain events?
Okay, so for all of this I use here the satellite images, and for the some of the land cover classification map as a crop classification map, then I use here the ground truth data.
What I meant is weather station rain measurement. Did you have to use it in any stage?
So actually this is the satellite images, so I will get this data from here, and if you have the any satellite or weather station data, then we can also import this data in the Google Earth Engine platform, and we can also work with this.
Is rain data available anywhere we can export it?
Yeah, we can export it. Yeah.
No, ground station rain events or measurements.
Yeah, we can also
Can we get it from anywhere?
yeah, we can get it.
Okay, thank you.
Okay. So anyone any question? Okay, so if you have no question, then our today's session will be end, and I will send you this all of this video, and also send you this all of this practice code, so that you can easily practice. And if you have any problem regarding these classes or code, then you can just knock me, and I will try to my best for help you, no problem. And tomorrow we will start the same time, okay? And tomorrow we will complete it our all of the rest of things for the Landcover classification map, then the air quality monitoring, then band calculation or other things. I will complete it the tomorrow session, and tomorrow session is our last session, okay? So thank you for joining with us. Okay. Okay, goodbye. Thank you. Okay.
Thank you, goodbye.
Record